All right, I'm going to try and give you a shortcut on how to borrow with mixed numbers. So when we get to the next video that talks about subtracting using mixed numbers, hopefully you've got this under your belt and you got the basic concepts. All right, what we have to understand is, and why this works, and that way your borrowing will go by a lot faster and you'll get a lot more right answers. What we have to understand is 5 1/3 is the same as 5 is the same as 4 plus 1, but I also have that 1/3. Okay? So 4 plus 1 gives me my 5, and I have my 1/3. Now, what I want to do is to borrow, because my numerator is not big enough and I need to borrow in a subtraction problem, okay? I'm just thinking, I'm going to take this part, so I'm going to go ahead and write the 4 down. I'm going to take this part and change that into, sorry about that, I'm going to change this into an improper fraction, which means the numerator is bigger than the denominator, okay? So I'm thinking, okay, some of you may have remembered from 4th grade, 3 times 1 is 3, plus 1 is 4, and we keep our denominator, okay? But why does that work? Because 1, remember, if you looked at my other videos, 3/3 is the same as 1. So 3 plus 1 gives me my 4 over here, okay? All right, so I'm going to notice a pattern, all right? So now I'm going to take 4 4/3, and I'm going to think, well, 4 is the same as 3 plus 1. I'm going to go ahead and bring down that fraction. 4/3. So what does that equal? Well, I got my 3, and I'm going to take this, I'm going to change it into an improper fraction. So my denominator will not change. I'm going to think, okay, well, 3 times 1 is 3, plus 4 is 7. And I notice that, well, why is that a 7? Because, and why do I go 3 times 1? Because I can write this 1 as 3/3. Why do I do 3/3? Because that's a 3. If it were a 4, it'd be 4/4, and so on, okay? So that equals my 1. So that's going to equal my 7. All right? So I'm noticing a pattern here as I work. I notice that when I'm borrowing, this was a 4, and what is 3 plus 1 equal? 4. I notice this is a 7. What is 3 plus 4 equal? 7. And why does that always work? Because I'm always changing my 1 to that into a fraction with my numerator and denominator the same as whatever my denominator happens to be. So here's the rule, because this explains why it works. 5 1/3 equals, this is minus 1, that's a 4, and then I just add these two numbers together to get my new numerator, and I keep the denominator, okay? If I want to borrow again, the 4 becomes a 3. I'm going to add those two numbers again. That's going to be my 7/3, right? This one I'm just adding. If I want to borrow again, 3 minus 1 is a 2. I'm going to add those two numbers. 7 plus 3 gives me 10/3. All right? And why does that work? Because I'm going to 3 plus is the same as 2 plus 1. I'm going to put that 1 as 3/3, so 3 plus 7 gives me my 10. Okay? I want to borrow again. Minus 1, so that's going to become a 1. 3 plus 10 is 13/3. And if I want to finish it all the way up, minus 1 is 0. 13 plus 3 gives me 16/3. So here from 5 1/3, I borrowed 1 time. I borrowed a 1 here, another one, another one, another one. Okay? Well, let's make sure that's true. How many times does 3 go into 16. It goes in 5 whole times. There's my 15. I've got 1 left over. I've got a remainder of 1 out of how many? Out of 3. And what did I start with? 5 1/3. So here's a shortcut on how to do some quick borrowing for subtraction problems. All right, now I'm going to put up a number, and I want you to go ahead and borrow. And we're just going to keep borrowing 1, borrowing 1, borrowing 1, and just keep going. And just to practice the pattern, okay? So let's go ahead and start off with 4 1/5. So remember what the pattern is? Take the whole number. 1 less than 4 will be a 3. I'm going to add 5 plus 1 to get my new numerator, which is a 6. And remember, your denominator never changes, okay? So we're going to go ahead and add those. If I'm going to borrow again, what's that whole number going to be? You're right, it's going to be a 2. Hopefully you said a 2. Because 1 less than 3, right? That's always minus 1, is a 2. My denominator is not going to change. What's going to be my new numerator? Well, what do I have here? I have a 5 and a 6, which means that's going to be an 11. All right, let's borrow one more time. What's 1 less than 2? It's going to be a 1. My denominator is not going to change. What's my numerator going to be? Okay, hopefully you got it right. 11 plus 5 gives me 16, right? If I borrow 1 last time, 1 less than 1 is a 0. My denominator does not change. 5 and 16 gives me 21. All right. Does 21 over 5 equals 4 1/5? Because we borrowed and borrowed one more. Let's go ahead and look. 5 goes into 21 4 whole times. That gives me 20. I've got a remainder of 1 out of how many? Out of 5. And lo and behold, that is what we start off with, 4 1/5. All right, so now let's go ahead and try some practice on your own here. Go ahead and write down 7 2/3. And you're going to borrow 1 on each step. So you're going to borrow 3 times. So let's go ahead and see. First question you need to ask yourself is, already we know what the denominators are of each of these fractions. Okay. Why do we know that? Because the denominator never changes, right? It just tells me the size of my pieces. So I already know those are all going to be a 3. Because that's never going to change. All right. So go ahead and try that and see if you can do it. Go ahead and stop the video for a second. So I'm going to borrow 1 from the 7. So 7 minus 1 is a 6. And what is going to be my numerator? My numerator is going to be, what's 3 plus 2? 5. Okay. What's 1 less than, I'm going to borrow again. What's 1 less than 6? That's a 5. What's my new numerator following the rule? That's right, it's got to be an 8. Because 3 plus 5 gives me my 8. I'm going to borrow from this mixed number right here. What's 1 less than 5? That's going to become a 4. And what's going to be my new numerator? That's right, 8 plus 3, or 3 plus 8, will be an 11. Okay? All right, so hopefully that will help you learn how to, kind of a shortcut to borrowing with mixed numbers. So when we get to fractions where we need to borrow, you already have that concept down, and you won't have to spend too much time thinking about, oh, what am I doing over here? Okay?